So we looked at specific, if you like, process-oriented tools. You can talk about one. That system dynamic that he showed is one type of tool. There are many other tools in the Office of Research and Development and others around the world are using, and I'll talk more about these, but they're tools like life cycle assessment that look at sort of a whole suite of issues that impact on the ecosystem. There are tools like risk assessment that look at chemical and microbial and human health impact assessments, so we look at the health side of things. And on the economic side, there are various tools from simple net present value through to benefit cost analysis through to life cycle costing of the whole sort of system infrastructure over its lifetime. And so we use these sorts of tools to aid our sustainability assessments. And then the other critical thing here is how do we make decisions? If you sit down in a room with engineers, water engineers in particular, they'll come up with a solution which you can guess now what it's going to be pretty well. Now that's a bit hard on some of the engineers, but it's pretty true from experience. So it's critical to get a broad range of stakeholders in the room to make decisions. And so in the Swedish program, we came up with this conceptualization. So we've got users, we've got organizations like EPAs and other regulators, and we've got technology. It's not static, it's a dynamic in how these interact. And the way we assess sustainability then is across the bottom here with human health, environmental, economic, the sort of traditional three pillars that we've heard about before, but we split out a couple more. The engineering side, on the technical functionality and resilience of the system is a very important issue. And the social cultural aspects, you know, how do people think about water? Depending on where you are in the world, water has a huge spiritual and other sort of properties to it. And so you need to be cognitive of those sorts of aspects as well. And so this is these suite of things that we can look at using various tools, and we can do this with a group of stakeholders in a room who are representative of the society you're making the decision for. And in the jargon, we call this multi-criteria, because the various criteria, and it's decision aiding. They're just helping the decision makers, they're not telling the decision makers. And so it's a multi-criteria decision aiding process that the group or committee of stakeholders understand the nuances, the various dimensions of measuring so-called sustainability. So I want to give you a couple of examples of how that's been rolled out in the city of Stockholm and that I've been involved with, and also in Australia in developing this approach. Hammarby was the first sort of dockland redevelopment just in the city of Stockholm, and this is a diagram of how it is today, and I know the print's far too small to see things, but there are things like solar panels on the roofs, green gardens. This is the road runoff that is treated through this urban riverine sort of system, or pseudo-riverine system, so it adds value to the properties of this community. There's an open market, so it's all about livability. People walk, there are a few cars, there's one roadway through here, and then the rest is walkways and bikeways. So it's the whole caboodle in the planning process. Current one, which is just happening at the moment with the same team. Actually, by the way, the students who are involved with us in that program on Hammarby have now started their own little company, and they consult. One of the consultancies they're working on is this Royal Port redevelopment, and it's much the same sort of scale, 10,000 new residents and things, and so you can see the sort of scale of this and some of their priorities of carbon emissions, free of fossil fuels, and these sorts of goals and aspirations are going to be met by those dates. And this is just the city of Stockholm. This is the greater Stockholm area. This is really downtown Gammelstad, those of you who know the old castle area. So this is Hammarby down here. This is the Royal Port development. And these are the other developments happening. So what's happening is the whole city of Stockholm from the outside is being re-engineered as to move into the core of the city centre. And the same is happening across in Göteborg or in Gothenburg on the west coast and other parts in Scandinavia. They're going through the same sort of master planning process. Not to bore you with too much of it, but the same core principles are here: economic, social, and ecological issues, all under the umbrella of what climate change may impact on those. They then focus in on areas for living, eco-efficient building and transportation, eco-cycle, so this is where the water sanitation fits in, and solid, I won't use the word waste again, solid residuals and reuse occurs, and energy systems are in that, and adaptation to climate change. So, by the way, in the Office of Research and Development, we've re-split our whole 2,000 researchers now into these categories. So we're sort of trying to frame ourselves into this sustainability paradigm. In south of Brisbane, we worked with the first approach of this in the QMRA program, which is the Gold Coast. It's the most rapidly growing part of Australia. And so just to give an example, they first sat down in a room in 2002, established a sort of planning group and stakeholder. They had 18 months where about 20 people sat in this room periodically, chaired by an independent person, and the water utility people sat on the outside of the room and were only asked to speak when asked for specific technical components. The committee ran the whole process. So they went through this in an 18-month process, and they looked at how they're going to build this community for 300,000 people in this new, so this is a greenfield development area. 3 minutes ago, thank you. And you know, I won't bore you with all the things, but water sensitive urban designs, that's the stormwater management side, the smart sewers. So these were considered essential in any of the options. There were initially 10, brought down to 5, and then down to 1 option that was finally selected on, and now it's being constructed, and it's now operational. And sort of use of rainwater and the use of recycled water, anything from firefighting through to other purposes. So these are the sorts of things that the community came up with and is now building and putting into place. I want to put a straw man up on the diagram here. There's a poster over there that explains a bit more if you have a chance to have a look at it. But before I say that, I want to just put something up which might sort of switch a light bulb on upstairs. There's money in the sewer and we're wasting it. There's energy in that sewer and we're wasting it. Here in this development in southern India, what's going on? They pay you to go and use the public convenience because they sell that urine as fertilizer and the composted fecal matter as soil amendment. So they pay not only for the establishment of putting in sanitation in areas that did not have it before, but they pay you to use it. Okay? Why doesn't a corporation pay you for your urine to get rid of your phosphorus and nitrogen and other issues? Think about it. So here is a straw man sort of diagram of what a house in an urban or suburban or even a more remote rural development like here could have. Now, there's a lot in here. I don't want to bore you with too much, and I'm out of time anyway. But let's just start with water can come in. If you've got mains water, you only need something like 20% to maybe 15% of a conventional household use of water. And the reason being that the black water from the toilet and from the food waste disposal unit could go through a vacuum sewer, which is a very small bore, direct drill. You don't need to dig a trench. It's much more cost effective to put in many places. And the purpose of that is locally for energy and nutrient recovery. So you turn into methane, you burn that methane when energy demand is needed, put that back into the grid, and waste heat, so-called, is used to help pelletize or condense down to produce a portable fertilizer. And so you can take that back out to agriculture where it came from. In the home, most of the water is grey water, and so that is captured and treated either in the basement if you're in a cold part of the world, or outside if you are living in somewhere like Sydney or Florida. And before it goes there, that's the hot or warm water in a house. So you put a heat exchanger on there to capture that heat, treat the grey water, use it for clothes washing, toilet flushing, garden irrigation, and you preheat your water supply there with that heat captured heat pump. Okay. Just to quickly go through now, you're all familiar with septic tank absorption trenches. They all fail because of lack of maintenance at some stage. You don't pump out the septic tank and or your absorption trench blocks, or if you're in this part of the world on a glacial area where you don't have enough soil or you've got high water tables, they're not designed for this part of the world. You would go to aerated wastewater treatment systems, which is a lot of what happens in various parts of Australia, to replace septic tank systems. These guys can only go in Australia if you have a maintenance contract guaranteed with a licensed plumber. Otherwise they're not allowed. But they also don't treat for nutrients, and people misuse them, and so there's, you can see what's happening here, perhaps there's a hose going out in the garden, and there's overland flow, and so you end up with nutrients and or pathogens washing down your curbs, going back into your riverine system. So these aerated systems actually fail from a nutrient and pathogen point of view anyway. So we can go to waterless systems, and I know some of you are very familiar with. I've had a composting toilet at my house in Sydney for 10 years, so I'll show you that in a minute. There are various other sorts of systems. That's a grey water system. It costs not a great deal of money. You can fit on the side of a house or on the basement of a house. I put a vacuum flush toilet system, composting system in my house in Cincinnati. There you only use 0.4, or use 300 mils, a very small amount of water to flush the toilet. This is my toilet in my house in Sydney. It's a urine diversion, which actually, the urine pipe is here, and you'll see downstairs in a second where it goes to, underneath my dining room table. And why do we do that? Because you can see on the left there, 80% of the nitrogen, about 60% of the phosphorus and potassium is in the urine stream. And yes, it's less than 1% of the flow of the sewer. So why blend it in with the grey water and everything else if that's the problem you're trying to solve? Other urine diversion configurations exist. This is under my dining room table in my house in Sydney. So this is a cubic meter tank, ex-Coca-Cola concentrate actually. I've filled it with a better brew. We worked out that if you store this for a few months, the pathogens are naturally inactivated. So it's hygienically safe. So in Sweden, it's allowed to be used after a few months storage. So I store it there and use it for my macadamia nuts and citrus I have in my garden in the house in Sydney. Or else I would sell it to somebody who wants it. The rest of the sewage comes down through this really ingenious little thing made by a Swedish company called Aquatron that basically water flows through in this spiral, comes to this curvature, feces and paper and solids go into this worm composter, and after 2 years of the beautiful humus I put on my garden, and the separated so-called brown water then goes through a UV light system and infiltration system of the soil. So, there are ways of dealing with issues that exist. And just the last thing, because I know I'm over time, what's in the pipeline, sort of pun intended, to reduce from 40 litres per person per day down to 13 gallons per person a day in the home. There are, in addition to the vacuum toilet you've just seen, which is commercially available, there are air flush toilets like this one that's made in the UK. In Victoria, in Australia, there's a company that makes, you can buy these very sort of upmarket showers that after a few minutes you put your foot on a button that goes into recirculation mode. So you can have a shower all day and use no more water and very little more energy because it has a heat exchanger. A really neat invention, huge savings in energy and water. And there are washing machines coming onto the market, so these are what you might call first generation, that use little nylon beads that solve. So you use a glass of water, a bit of detergent, and you wash your clothes, and those beads solve the contaminants, if you like, and they last about 6 months, and then you need to change out those beads with a fresh lot. And we need to think about, again, the life cycle issues associated with those beads, but at the moment, I said it's a first generation thinking. So there are other technologies coming in here. And all this means, of course, is there's an awful lot less wastewater to treat in the new houses or houses of the future that are using these sorts of technologies. That makes a big difference to the footprint of whatever you're going to put in for your residual recovery system. So to finish over time, my apologies, we need to use these 3 pillars as the framing. We need to be thinking about the health, environmental, economic impacts. There are tools that we in EPA and others around the world are developing, but there aren't off-the-shelf things. Ken mentioned one of the earlier products in the sense of this system dynamic tool to help look at the bigger picture. But really importantly, we probably have the wrong economic and governance structures today to actually solve the problems. We need to think about what are the financial incentives that are going to make these other alternatives I've been alluding to actually happen. And I think that is a fundamental thing that needs to be worked on concurrently along with the technology as well. So thank you.